So in this video, I'm going to demo what I'm calling recursive project search and how I do that in Emacs. So this is where you do some kind of search task, maybe searching for all usages of a function to modify them. But then that leads you to another search task and possibly to another and another. You need to complete all of the sub-searches and their tasks, but without losing your place in the parent searches and the overall task. And this kind of thing is extremely common in software development and maintenance, whether you're just trying to scope out a set of changes or whether actually doing them. In fact, I find that just about any task can end up being some form of this, even if I didn't anticipate that from the start. So, as a quick overview of where we're going in this video, I'm going to show a demo of the workflow that I use for this in Emacs. Then I'll explain how it works and what the necessary ingredients are. And finally, I'll provide some of the Elisp snippets that can help make this work really smoothly in Emacs. So let's dive in with an example. I'm going to use my project PyAST grep and a fairly simple refactoring. You don't really need to understand this project, but for background, it's a command line tool and library that allows you to grep Python code at the level of abstract syntax trees rather than just strings. At the heart of this is a function that takes a Python path and converts it to AST and XML. So it's this function here, process Python file. Now I want to make this function swappable. So that's mostly so that users can apply different caching strategies to it. So this is going to be a straightforward example of turning it into a parameter wherever it's used, or a dependency injection if you want a fancy term. But that may involve modifying a number of functions in a stack of function calls, which each one's going to have to pass this parameter through. So I'm going to start off with a search to find where this function is used so that we can make it into a parameter. But before we get going, I'm actually going to close all my other buffers because later on we'll be using the open buffers as bookmarks to help tell me where I'm up to. So I've got a function which does that, kill other buffers. So we're just left with this one. So now I'm going to select process Python file, and the first search I will do will be an Elisp search for references to it. So that's returned my list of results. I can step through these results very easily using Emacs next error, like this, or Emacs previous error to go back. Or I've got shortcuts set up for this, F2 and Shift F2 in my case. Now, notice that the search results is keeping track of where I am, both with the cursor and also this little triangle here. So in this case, after the function definition itself, which is this first result, I've got then an import and I've got just one usage of the function. And here's where I need to make this usage into a parameter. So I've got type hints in this project, so I'm going to need the type signature of this function. So I'm just going to copy that over and make a parameter for that. Let's call it Python. I'll make it a keyword only argument. Python file processor, and it's going to be a callable which takes just a path and returns either process Python or read error. It looks like I now need an import for that, and then I actually need to use that parameter. I need to give it a default value, which is process Python file, and then I need to use it. But that's the basic first step. I'm going to make a copy of this function, this parameter, so I can use it for the next step. That was the first step. I've added this parameter to this function search Python file, but now I need to continue this refactor. I've got to search for all usages of this function search Python file. So let's do the same. Elisp find references again. This time I just need to propagate the usage. I need to add a parameter, a similar parameter here. And I just need to propagate that down. So that's dealt with that one. But now, before I go on, I've got to find all usages of this function, search Python files. So this function is, we find first of all, it's been imported into the API module. It's then just re-exported, so it's not actually used here, but it's reminded me of something really important. This function and the new parameter to it are going to be a part of the documented API interface. So now I need to grab the docs for the place where I've documented this function. So let's start and do a different kind of search, this time a project-wide grep search, and I use ripgrep for that. I'll do project all files. I want to search for search Python files. This has actually returned a few too many results because I'm already dealing with the Python results in this search. So I just wanted to search the docs. So I can bring up the menu to modify this search. I'm just going to change the files here to be RST files instead. So I've got these two results in the documentation that I need to step through. And for the purposes of keeping this demo short, let's just leave a to-do comment in here. So let's pretend now that I've done that. I've documented my new parameter to that function. I continue stepping through the results. That's fine, I don't need to change that. But now comes one of the critical points in the workflow. I've come to the end of a task. I've come to the end of this search buffer of results. I need to carry on with what I was doing before. I've got all the other searches that I was only just part way through. How do I carry on with them? Well, I can close this window down after saving it. And then I just need to kill this buffer. Control XK or whatever function, whatever shortcut you use for that. I've killed the buffer. Now look where I am. I'm back at my previous search buffer in exactly the same place that I left off. And that's a critical point, that the buffer has remembered where I am. So I can just carry on with what I was doing. So I just need to keep going through the results. So in this case, now we're back to search Python files, and I need to possibly modify all usages of that function. That's an import, don't need to change this. This is the CLI usage. For this case, the command, the default value of the parameter I added is fine, so I can just carry on. Here's the function definition itself, carry on. Test library, I do actually need to make a change here. I need to add a test for the new parameter. So let's add that as again as a to-do comment. Let's again pretend that I did that and carry on with my results. That one's fine. That's fine. And this is a test utility. Again, that's fine. I can accept the default for there. Again, I'm at the same point. I need to I've got to the end of a search buffer, what do I do? Well, I kill that buffer and I'm back where I was before. Now looking for usages of search Python file, which I've already fixed up. So that one's done. I can kill this. I'm now on my last result of the very first search that I did, and I'm done. I've fixed that one up. And that's the end. So I've gone through all my search buffers. I've finished them all. I do want at this point to just check that I didn't lose any of my searches along the way. So I can just do that by listing all my buffers. Now I can see I've got a bunch of files open, a bunch of buffers open, but none of my search buffers are open. I've got rid of them as I completed them. So I'm done and I haven't missed anything. Now let me just explain what just happened, what I was doing there. What I've basically done is a depth first recursive search over everything that needed to be done to complete the task. So I started working on one thing, which led me to another and another. And for each one, I went off and completed the subtask as it came up. Now, doing a search like that requires keeping track of a fair amount of states, just like it would be inside a programming language that was doing a recursive search. If I were doing that and trying to keep it all in my head, I would get lost very quickly and forget what I was doing. So what I do is I use Emacs buffers to maintain all of that state. The buffers themselves form a stack, and each buffer within it has a cursor which tells me how far through the list of results I've got. Now in this case, it only went about 3 or 4 levels deep, and each level was fairly short. But you can go much deeper and not get lost because the buffers are keeping track of all the state you need. You know, you can be 12 levels down, deep in the woods, and then you can just put it to one side and come back after lunch or the next day and just carry on because the buffers are remembering everything for you. And then the buffer that's in front of you, it tells you what you were working on last and what you need to carry on with. It doesn't even matter if you switch between buffers and get them a bit out of order. All you have to do is ensure that you get to the bottom of each one, you complete the search, and then you just move on to the next one. Now, another important feature of this is that you can use different kinds of search and mix and match them as you need. For example, you saw me do an Elisp find references and also a grep search. So this isn't a feature of just one mode. It's a feature of how buffers work together. Now, this workflow, I think, is really powerful, and it enables me to do things that some people I've worked with in the past simply couldn't do with their tools. And in fact, I couldn't do it with their tools either. This kind of workflow is actually one of the things I miss soonest whenever I attempt to use other editors and IDEs. Now, there are a few things you need for this to work really nicely. So the first is this, that search buffers have this ability to remember your position, which is something that all Emacs search modes do because they've got that cursor there. Secondly, you need an easy way to step through results, and this is provided by the really convenient Emacs, the next error function, which does exactly what you want. That function is part of the compilation mode or compilation minor mode, and all the search modes I've seen use it correctly, and you can look up the docs for it to see how it works in more detail. And then thirdly, you need a new search buffer for each search. That is, search modes mustn't reuse buffers for different searches. Otherwise, you'll clobber the earlier search results that you hadn't finished processing. Now, for this last point, some search modes already do what I want out of the box, but there are others which do reuse buffers by default. However, it's pretty easy to override behavior, so they automatically always get a unique buffer for each new search you do. You'll need a little bit of Elisp code. I'll put all this code in the accompanying blog post, but I'll also show it briefly here. It is in fact slightly different Elisp code for each mode, but the basic principle is similar. Different searches should get different buffer names. So here are the main ones that I override. First of all, there's RG mode. This has actually got a built-in functionality called saving the search, which basically just means that RG won't reuse the buffers when you do another search. And all we've done here is we've added that functionality as a bit of advice so that it runs at the appropriate point, and it means that you never reuse buffers. So that's just automatically using a built-in function of RG mode. Then for Elisp find references, I've got this bit of code, and this similarly, it gives a unique name to each buffer based on the symbol that you actually searched for, so that then when the next time it does a search, it doesn't reuse the previous buffer. And then for the general Emacs compile, this compile or projectile compile project, this is the tweak I use. This just applies a unique buffer name based on the command line that you actually called. Now, I actually use compile mode or equivalent commands quite a lot to run all kinds of external shell commands. Then they don't have to be what you might think of as an actual compilation. For example, I use it for custom search commands like piast grep itself. I use it for linters and static type checkers and that kind of thing. Many of these tools already have output that's exactly the format that Emacs expects, so that search results or error messages become hyperlinked just as you would expect and want within Emacs. A few of them don't. Some of them need command line arguments to make them have the right format. Some of them you can easily make custom wrappers that fix the format. So for example, there's this one, is Pywrite Emacs. This is just a little shell script I've written which wraps Pywrite, and all it's doing here is actually just adjusting the white space that makes it exactly the right format for Emacs, so everything becomes hyperlinked and you can just step through the results one by one. But the main point is that you can actually use any custom shell command and get the results in a compilation window, and then you can use the same technique of stepping through the results one by one and using it as part of this bigger workflow. Well, that's it. Thank you very much for watching. I hope it was helpful. As a reminder, for all the Elisp snippets that I showed, please just check out the accompanying blog post.